In this tutorial, we're going to learn how to fit simple linear regression models, or the least squares regression model, using R. And the way we go about that, first thing, I just want to point out that I'm in the Chapter 2 PC text data files, and I have my R console here, so when I open it up, it'll automatically be in the correct directory. So I open it, and now what I want to do is import a data set. So this is the data set I'm going to import. I have not imported it yet. So this is exercise 2.7, and the way I'll so this is I just defined a variable, and now I'm going to use the read.table function to import the data set. I need to write down the variable name, and then I need to specify the extension. It's a text document. And there's one more thing I need. You'll notice that there are headers in this data set, so I do need to let header equal true. When I press enter, oh, I used a capital H. Sorry, that should be a lowercase h. Okay, now we have the data stored. And we can see that has been correctly imported. So what I'd like to do is I'm going to make a new script, and basically what this does is this just gives me like a text document. It's like something I can edit text into. Okay. So what I'd like to do is to plot the data. And when I plot the data, you'll notice that speed is treated as the explanatory variable. And the reason why, the default is that you have your x and then your y. So this will be treated as the explanatory variable when I punch it in like that, and this will be treated as the response variable. Okay, so now what I'd like to do is to fit a linear model. The way that you fit the data, the least squares model, is by the LM function. L for linear, M for model, and then the first thing you need to put in there is the response variable. In this case, the response variable is fuel. Then you need to put a tilde. This tilde acts as a separator between the response and the explanatory variable. And you need to put in the name of the explanatory variable. In this case, the explanatory variable is named speed. And there's one more thing. I don't have these objects stored as a I don't have the fuel object stored in the separately. So if I type in the word fuel, it'll say object fuel not found. Same thing with speed. So there's several ways you can go about correcting this. First is you can actually define which one goes to what. So speed is the first column of data, the data frame data. Just to show you. So we have 10, 20, 30, all the way up to 150, 10, 20, 30, all the way up to 150. So that has now been stored. Similarly, we can do the same thing with fuel. The fuel variable is stored in the second column of capital data. So it's this column right here. And we'll just plot data one more time. Okay, so we'll see 20, 13, 10, 20, 13, 10. So now fuel and speed have been stored as objects. We can actually fit the model now, just like this. If you don't want to store them as objects, what you can do is this: data equals data, and you basically just tell R what data set these variables are found in, and it will work just the same. Okay, so you'll notice there's a little bit of output here. They're identical, as well they should be. So you'll see coefficients, and you see intercept and speed. Basically, how you interpret this is the intercept of the line, and this is the slope. This is the slope for that line. And the variable here is speed. Okay, so that's great. You can actually fit the least squares regression line in R and get the intercept and slope. But what about plotting it? We would like to plot this. So there's several ways you can go about this. You can actually point this. This is actually a line object. You can actually point this to a variable we'll call let's call it y hat. And every time we type y hat now, it will give us the same thing as if we just type this. Not necessary, but we can actually get the predicted values by using the predict function. So when I press enter, predict, this linear model, what it'll give me are the fitted values for each particular x. And we can actually plot these predicted values. I'm going to change this to y hat. I'm going to define y hat as these predicted values. And if we want to plot the regression line, we can use the lines function. And basically what the lines function does is it takes whatever plot you have and it adds a line, whatever line you want. It's just like the plot function, only it adds a line to your current plot. So I'll use the lines function. The first thing you should put is your explanatory variable. The second thing you should put is your y variable. In this case, we're going to be putting the predicted values in. When I press enter, it will give me the least squares regression line added to this plot.